The Imperial Japanese Navy heavy cruiser Furotaka was built under intense treaty-era displacement pressure, forcing hard trade-offs in protection, stability, and endurance. Even after her late 1930s reconstruction, her gun houses carried only about an inch of plating at most, adequate against splinters, not heavy armor-piercing fire. When a radar-directed American cruiser and destroyer force struck out of the darkness at very short range, that thin turret plating became a brutal limit on what the ship could endure. With the flagship burning and the formation coming apart, Furutaka broke station and turned back into the melee, an instinctive move to buy the line a few more seconds. The cost of that decision was about to be paid in steel, and the roots of that cost went all the way back to her design. Furutaka was Japan's first heavy cruiser, engineered for speed and striking power under hard displacement limits. The trade-offs showed everywhere: protection pared down, margins tightened, endurance bargained away, so the ship could carry the punch the Navy wanted. The most dangerous compromise sat out in the open: torpedoes that used compressed oxygen, mounted and exposed above deck launchers. That arrangement made the battery brutally effective and brutally vulnerable. Splinters and fire near those tubes could turn the ship's own warheads into a secondary blast source, multiplying every other wound the hull was already taking. During the Battle of Cape Esperance, this fragile architecture met its absolute limit. In the darkness of the Pacific night, an American cruiser and destroyer force achieved complete tactical surprise. For relying on early radar targeting, they closed the distance until, at moments, the range fell to roughly 5,000 yards. Very short range for a night gunnery fight. At this extreme proximity, heavy naval shells do not plunge from high arcs. They travel on flat, high-velocity trajectories, carrying overwhelming kinetic energy directly into the vertical flanks of a target. Furutaka was caught in a lethal, unavoidable bracket of continuous fire. The flagship Aoba absorbed the first devastating salvos of the ambush. With the admiral mortally wounded and command and maneuvering disrupted, the flagship was in grave danger under the opening salvos. Furutaka was perfectly positioned to evade the trap, but her commanding officer, Captain Tsutao Araki, recognized the imminent collapse of the formation. He calculated the geometry of the incoming American fire and ordered his helm hard over. He drove his cruiser directly between the firing line and the crippled Aoba. By placing his ship into the line of sight, he presented a massive physical barrier to block the enemy tracking solutions. By swinging broadside into the line of fire, Furutaka absorbed the concentrated barrage meant to finish the flagship. At that knife range, her gun houses and upper works were little more than splinter shields. 6-inch and 8-inch hits and razor splinters walked the upper decks, lighting fires and forcing water into compartments that were never meant to flood. Over the course of the engagement, she was reportedly hit about 90 times, a punishing way to fire for a lightly protected hull. Everything about the design said the deck-mounted oxygen torpedoes should have gone up fast. One clean catastrophe that ended the fight in an instant. Fires and secondary blasts flared around the fittings, yet the accounts do not point to a single decisive chain reaction that snapped the ship in half on the surface. The kill came the slower way, hit after hit, flooding spreading, machinery failing, power draining out. Furutaka lost all power and went dead in the water, burning, paralyzed, and drifting as the fight slid past her. Progressive flooding overwhelmed internal boundaries faster than the teams could isolate breaches. Water surged into the forward machinery spaces, stripping buoyancy and dragging the hull lower by degrees. Then the balance finally tipped. She sank stern first into the pitch black, and the surface battle moved on, leaving the cruiser to begin her long, violent descent. About 4,600 feet below the surface of Ironbottom Sound, the ocean sets hard limits on human reach. At that depth, pressure, darkness, and cold make conventional diving impossible. It is still accessible, but only to deep-rated robotic systems operating in near-total blackness. And those same punishing conditions can slow parts of the wreck's decay. The site is not frozen, steel still changes, and chemistry still works. But deep, cold, low-oxygen water can preserve damage patterns long enough to read the story stamped into twisted plating and shattered frames. The physics of the deep ocean are only the first layer protecting the shattered hull. The second barrier is legal and political. The widely recognized principle of sovereign immunity. and under which sunken naval warships are generally treated as continuing property of their flag state. Because these losses occurred in combat and involved heavy casualties, many sites are also regarded as war graves, carrying an ethical duty of non-disturbance. Without the flag state's express consent, intrusive actions, recovery, cutting, sampling, or physical alteration risk being both unlawful and profoundly unethical, pushing serious expeditions toward documentation instead of disturbance. Together, these twin barriers construct a profound operational paradox for any modern survey mission. The expedition team confronts an environment that instantly crushes conventional exploratory equipment, combined with a legal framework that forbids even the slightest physical contact with the hull. The central objective of the mission is to achieve a positive forensic identification and to complete a comprehensive condition assessment of a massive, heavily fragmented warship. The team must verify historical assumptions regarding her final structural state and the violent forces that tore her apart during her descent into the abyss. They must prove her identity beyond a shadow of a doubt, but every critical piece of physical evidence is securely locked behind thousands of feet of crushing hydrostatic pressure and an ironclad international legal firewall. The mission architecture must pivot entirely away from traditional mechanical salvage techniques. Physical recovery is definitively off the table. Intrusive structural sampling is legally impossible. If the operation morphs from an industrial lifting challenge into a complex problem of remote spatial mapping and high-resolution imaging. To solve this paradox, acoustic engineers must devise a meticulous strategy to safely navigate the lethal deep ocean environment. They must find a way to perfectly visualize, accurately measure, and definitively identify a massive, chaotic debris field that they are physically and legally forbidden from ever touching. Oceanic water absorbs visual light completely within a few hundred feet of the surface. To search the abyssal plain, an expedition cannot rely on cameras or human eyes. The environment enforces an absolute sensor blind spot where optical clarity drops to zero. Finding a shattered warship in this darkness requires stripping away the visual spectrum entirely and relying on the physics of sound. The team must map the ocean floor using an acoustic grid sweep. This method dictates the systematic sonar geometry required to locate non-contiguous wreckage across vast stretches of deep ocean topography without the aid of visual light. By projecting concentrated pulses of sound toward the seafloor and measuring the precise timing of the return echoes, autonomous vehicles can slowly draw a three-dimensional map of the pitch-black terrain. It is a slow, methodical process of mathematical translation, turning invisible acoustic waves into a readable topographic chart of the ocean floor. On February 25, 2019, the research vessel RV Petrel located the wreck after an AUV sonar search, a find that would later be announced publicly in early May. The expedition deployed an autonomous underwater vehicle to run tightly spaced, parallel flight lines over the designated search box. Flying continuously above the mud, the machine painted the seabed with sonar, hunting for the dense, unnatural acoustic shadows characteristic of heavy industrial steel. When the vehicle returned to the surface and downloaded its data, the engineers analyzed the raw acoustic returns. They found a massive, concentrated anomaly projecting sharply upward from the flat bottom, surrounded by smaller, scattered acoustic contacts. But sonar hits a hard ceiling of its own. It can prove something massive occupies the coordinates without proving exactly what it is. An acoustic shadow cannot read a nameplate, confirm weapons, or lay out the debris field in forensic detail. To close that gap, the expedition had to leave the map and go to the image. The crew of the RV Petrel launched their remotely operated vehicle to perform the final identification phase. Tethered to the surface ship by miles of fiber optic cable, the machine descended directly toward the primary acoustic anomaly. Yet the approach did not simply call for a straight drop onto the main target. Standard deep wreck practice is to widen the visual search and work the edges first, looking for outlying debris that can confirm what the sonar is seeing. Only after that broader sweep do pilots close in on the largest mass, building a clearer picture of the entire field without rushing the vehicle into unseen hazards. After securing the outer perimeter data, the pilot steered the vehicle toward the central sonar contact. High-powered floodlights sliced through the total darkness, revealing the massive steel flank of the warship. The visual evidence immediately confirmed the orientation of the wreck. The main hull of the heavy cruiser sits completely upright on the seafloor. Despite the extreme trauma sustained during the surface engagement and the chaotic freefall through the water column, the dense lower engineering spaces and heavy keel acted as a stabilizing pendulum. This physical geometry forced the remaining hull structure to right itself before impacting the bottom, driving the keel deep into the silt. The upright orientation provided the survey team with an unprecedented baseline for their condition assessment. They could systematically fly the cameras along the main deck line, verifying the placement of the remaining barbettes and the layout of the superstructure footprint. By cross-referencing the real-time video feed with original naval blueprints, the expedition began to build a highly accurate mosaic of the wreck site. They observed precisely where the internal bulkheads had failed and where the external plating had buckled under the kinetic stress of the sinking sequence. Yet, as the remotely operated vehicle continued its meticulous flight path along the ruined upper decks, the cameras illuminated a structural reality that defied expectations. The visual data streaming up the fiber optic tether began to sharply diverge from the accepted historical narrative of the loss. The underwater search team stared at their monitors, realizing that the immediate visual anomalies scattered across the upright hull completely contradicted the established sinking record. The true forensic state of the heavy cruiser was entirely different than the historical archives had claimed. Historical battle damage reports concluded that the heavy cruiser suffered a massive, catastrophic magazine detonation during her final surface engagement. The sheer volume of incoming shellfire was widely believed to have ignited her deck-mounted torpedoes, tearing her structural spine apart before she ever slipped beneath the waves. Yet, as the remotely operated vehicle illuminated the midship section of the ruined main deck, the live, high-definition video feed completely shattered this accepted narrative. The camera lenses focused squarely on the very weapons that were supposed to have obliterated the ship. The torpedo launchers were severely battered and scarred by shrapnel, yet they appeared largely intact. In the lights, shapes consistent with torpedo bodies could be seen seated in some tubes, suggestive but not proof of their internal condition. The undeniable presence of these intact weapons fundamentally rewrites the forensic understanding of the sinking mechanics. The ship had undeniably suffered immense kinetic trauma, absorbing numerous direct hits across her entire superstructure. Yet the volatile munition risk had not fully materialized as historians expected. The intense fires and violent shell impacts had somehow spared a significant portion of her most dangerous explosive payload. The continuous underwater footage proved definitively that a complete, instantaneous detonation of the torpedo battery did not occur during the surface ambush. While some torpedoes might have cooked off or been deliberately jettisoned by the crew, several remained fully armed and tightly locked in their firing positions as the ruined cruiser descended into the abyss. This unexpected discovery immediately triggered a rigorous, strictly visual analysis protocol known as a non-destructive munition audit. Because the wreck is a legally protected military war grave, the expedition team is absolutely forbidden from physically manipulating the volatile ordnance. They cannot cut away collapsed deck plating to measure the exact blast damage around the tubes, nor can they retrieve a warhead to conduct a chemical analysis of the explosives. Instead, the remotely operated vehicle must hover cautiously at a safe distance, utilizing focused lighting angles and high-resolution cameras. The pilots meticulously document the exterior condition of the torpedo casings, the structural integrity of the surrounding mounts, and the precise blast geometry of the adjacent deck. This non-destructive munition audit relies entirely on optical data and precise spatial mapping to deduce the internal state of the weapons, completely avoiding any physical contact that could alter their delicate chemical composition or risk a delayed deep-water detonation. That visual-only rule creates a hard-proof ceiling. The cameras can show what is present and what is missing, but they cannot open the tubes, sample metal, or answer the deeper mechanical question of why certain weapons did not detonate under extreme heat and shock. The expedition can correct the record on survival, but not expose the hidden failure cascade that made it possible. While the careful midship audit resolved one contradiction, the cameras immediately found a far larger anomaly forward. As the pilots guided the vehicle toward the ship's command center, the floodlights hit only empty water. The massive bridge structure, the silhouette that should have been welded into the armored deck as part of the cruiser's rigid spine, was simply gone. The main deck ended in a jagged cliff of torn steel where the tower should have stood, leaving a geometric void the descent record did not explain. To understand how an entire command tower can vanish from the primary hull, engineers look to the violent mechanics of a deep water descent. A falling warship accelerates through a dense, resisting fluid, and tall, irregular structures generate enormous drag. One plausible explanation is that battle damage weakened key joints, and the combined stresses of descent and impact caused the bridge to separate, whether in the water column, on the bottom, or through a combination of both. Once the massive bridge tears away from the primary hull, it no longer follows the rapid vertical trajectory of the dense, streamlined lower ship. The oddly shaped tower is caught by deep ocean currents and its own erratic drag profile, causing it to drift horizontally through the water column. It behaves like a massive, twisted metal leaf fluttering toward the bottom. To locate this crucial missing mass, the expedition pilots had to drastically expand their search perimeter, flying the remote cameras far beyond the immediate debris zone. They piloted the machine across the barren mud of the abyssal plain, tracking scattered debris until the cameras finally captured the looming, intact silhouette of the severed command tower. The enormous structure rests in total isolation, sitting about 2,000 feet away from the main wreckage of the heavy cruiser. Discovering the bridge tower at this extreme 2,000-foot offset perfectly resolved the intervention threshold for the expedition. The core mandate of the operation was to fully characterize the state of the wreck and the mechanics of its destruction without breaching the strict non-contact boundary. By meticulously mapping both the main hull and this distant outer debris field, the survey team achieved a comprehensive condition assessment of the entire fragmented vessel. They successfully documented the extreme physical trauma of the deep water sinking sequence and accounted for all major structural components solely through remote optical data. The operation proved that mapping the massive spatial gap between the sheared components provides undeniable proof of the violent descent forces. The engineers confirmed the fate of the ship entirely through observation, turning a widely scattered debris field into a precise, untouchable forensic map. With the main hull cataloged and the bridge tower located out on the plain, the survey could argue the class with confidence. But class is not identity. Matching silhouettes and weapon layouts satisfy history. They do not satisfy the legal standard that permanently locks a sovereign wreck under protection. To close the record beyond doubt, the team needed one unmistakable, historically documented signature that could be seen without touching anything. Pilots directed the remotely operated vehicle to execute a final sweep for the extreme forward section of the vessel. The cameras scanned the barren abyssal mud until the lights caught the jagged, torn steel of the separated forward hull. The entire bow had been completely severed from the main body of the warship during the chaotic sinking sequence. As the tethered machine slowly navigated around the isolated structure, the operators focused their lenses on the extreme apex of the stem. Emerging from the total darkness, perfectly preserved by the freezing, oxygen-starved water, was the ultimate prize of the expedition. Firmly attached to the ruined steel of the severed bow, the remains of the imperial chrysanthemum crest were still visible, enough to be recognized in the lights. For a team that will not disturb a war grave, that is exactly the kind of signature that matters. A distinctive, historically documented feature, seen where the design placed it, matched to plans and archival photographs without a single physical intervention. With the identity of the heavy cruiser confirmed to a high degree of confidence, the meaning of the site shifted. Clear attribution strengthens the case for treating the wreck as a protected state vessel and a war grave, and it helps remove any plausible deniability for would-be looters. The law still turns on consent and sovereignty, but the clearer the identification, the harder it becomes to justify disturbance. The survey mission reached its absolute conclusion. The expedition team mapped the chaos of her destruction, documented the unsettling survival of her volatile weapons, and proved the forces that tore her command tower away in the dark, without crossing the non-intervention line. Now the heavy cruiser remains isolated in the freezing depth. Crushing pressure keeps her beyond reach, and sovereignty and ethics keep hands off. She rests exactly as she fell, a silent testament to surface war, forever observed, never disturbed.